All right, welcome back. We are going to continue our discussions about different types of motion. Remember that our three types of motion were if an object is at rest or has zero velocity, if an object has constant velocity, that is constant velocity, or if an object is accelerating, meaning it has changing velocity. And what I want us to look at is I want us to talk about what some graphs might look like that what some graphs could look like for each of these scenarios. Now, we're going to talk about a couple of different kinds of graphs. We're going to talk about a position versus time graph, and we're going to talk about a velocity versus time graph. Now, a position versus time graph means that what I have on the y-axis, let's see, I'm just going to draw a couple of coordinate axes here. And on this axis, I have the position of the object. And then on this axis here, I have time going by. So in other words, we're going to track the position of the object as time goes by. And we'll do that for an object at rest, for an object with constant velocity, and for an object that is accelerating. All right, and again, all of those are going to be position versus time graphs. And so we'll have the position of the object on the y-axis and the time that is elapsed on the x-axis. All right, and then after that, we will make some velocity versus time graphs for the, some velocity versus time graphs for the same motions. All right, and I'll go ahead and draw those in there as well, and you can set up your notes also. That's not going to do. Yeah, let's fix that. There we go. Right. And so we've got some more coordinate axes drawn here, and these are going to be for the velocity of the object as time goes by. All right, so let's say that we have an object and that we would like to, let's just say that I'm going to put it at this location right here. Okay, so here it is. It's not at the origin. It looks like its position is, I don't know, maybe 1 or 2 meters away from the origin. And here's my question: if it's at rest, what will the graph look like? Okay, not just a straight line, but the line also will be completely flat. Yeah, because the object is completely still. And so it will look something like this. All right. And so the object, the graph will be flat, and it will be, and you can see that that's a constant position. The value of the position does not change. And so we have a constant position as time goes by. Now, what about an object that's moving with constant velocity? How would its position change? All right, so it's going to be straight but diagonally. So we'll have our line something like that. All right. Now, let me ask you this. What if I have two objects, one represented by the green line and one represented by the orange line? Okay. And let me ask you this. Which one is moving faster, and how do you know? Okay. Why do you think that the orange one is moving faster? Just guessing? All right. Hey, okay. Why do we think the green one's moving faster? Okay. Because I don't want to say more area, but sort of. What were you going to say, sir? All right. Hey, it's a steeper slope. And so the position is changing faster than the orange line. You can see that this position is changing that much every unit of time. Okay. Whereas this one's only changing, maybe half that much. And so we can see that the green one is changing faster than the orange one, and so it's moving more quickly. Now, what if let's put a yellow one in there, okay? And what if I put the yellow one far away and then bring it back toward the origin? Okay, in other words, its position is decreasing as time goes by. It's moving back toward the origin. Um, hey, how would you compare the speed of the yellow one with the speed of the green one? Which one's faster? Yeah, the yellow one. Why? Yeah, it's steeper. Okay, it's diving faster. Now, so it's changing faster. It is steeper, and that is why we know that the yellow one is faster. Now, it does happen that it's going in the opposite direction. The green one is going away from the origin, and the yellow one is going toward the origin. So they do have opposite directions, but which means they'll have opposite signs, but the yellow one is faster because it's steeper. Now, for acceleration, I'm going to tell you that um, it will be anything with a curved line. Okay. And so you can see how this is curved almost like an exponential function. And so anything that has a curve on a position time graph is accelerating. So a curve on a position time graph is accelerating. Questions about that? Let's go ahead and look at the velocity time graph. Now, if it's at rest, what did we say its velocity was? 0. And so in this case, we need a flat horizontal line, but we need it right on the axis. Okay, and so that should be right on top of the x-axis because it is at the 0 mark. All right. So that is an object that has 0 velocity and maintains 0 velocity. So it's at rest. Now, what if it's maintaining a constant velocity? Let's go back to our green one. If I say that the green object's velocity is right here, what will its graph look like? A flat line, a flat horizontal line. And it's because it has a certain value. Remember that we're talking about constant velocity, so the velocity's value doesn't change. So I said, hey, if it's got this value, it's not going to change the whole time. It's going to stay the same velocity. Let me ask you this. Where should I graph the orange one? Where should I graph the orange one? It's going to be in between. Remember, it's slower than the green, but it's still constant. So it'll be something like this. Yeah, that's where it goes. Um, And so the green one has a higher velocity, but it's still constant. The orange one has a lower velocity, but it's still constant. And the yellow one would actually be in the fourth quadrant. It would be down in the negative area. I'm not going to sketch the yellow one because I didn't leave myself enough space to draw the fourth quadrant in. All right. What about if it's accelerating? That means its velocity is what? Well, what's happening to its velocity? It's steadily climbing, it's steadily increasing. Okay, because we can see that this is moving a further and further distance for each unit of time. And so this is steadily climbing with its velocity. So it's going to start out somewhere like this and go up like that. All right. And so there we see an increasing velocity. If we, let's see, if we had something like, if we had something like this, let me draw a nice blue one like here. The blue one starts off with a high velocity, which then gets less and less and less as time goes by. And so it would actually do something like this. All right. And that might be what the blue one looks like. The point is, though, whether it's increasing or decreasing, the it is accelerating, it's changing its velocity. Any questions about our graphs? No? All right. Well, thank you so much for your time on that, and I hope you have a great day.